Hello, welcome back to Cinderella Math. This will be a video on implicit differentiation. So differentiating a function, well, doesn't necessarily, differentiating, sorry, it's late, with both x's and y's. So your function doesn't just have x. This is a Calculus 1 topic. All right, and I have a paper here that I'm just going to refer to. That first one was done, but I'm going to cover that up and do it again. All righty. So when you see x, just take the derivative as normal. So I'm looking at number 9. So the derivative of x cubed, we're going to pop that down. That'd be 3 subtract 1, so x squared. And then do the same thing when you see a y, but then we're going to do one extra thing. So right here, this would be negative 6 subtract 1, which would just be y to the first y. And then whenever you take the derivative of y, we're going to write dy. Now, some teachers write dy dx, which would stand for the derivative of y with respect to x. And dy is just a shortcut to not have to write that fraction. I have also seen other teachers write, instead of dy, they'll write y prime. So, and follow your instructor there. I like to just write dy, but you do whatever your instructor likes. Keep your equals, and the derivative of any constant is 0. Now we are going to solve for dy. So I'm going to go ahead and move this over. 3x squared equals 6y, because we're adding, 6y dy. And then I need to divide this off to solve for dy. 3/6 is a half, and you don't need the 1. So final answer, x squared over 2y is our derivative dy dx, or just dy or y prime, whatever your instructor likes there, the end. Okay. I'm actually going to clear the page. So if you're still needing that, pause me. If I went too fast, just slow the video down, or feel free to rewind. I need this whole page here for 10 because I'm going to do some side work. Because right there in the very beginning, these are being multiplied. So we need to do the product rule. Let me remind you of the product rule. It's f g prime plus g f prime. So our f in this situation is going to be x cubed, and our g is going to be y squared. That will give us an f prime of 3x squared and a g prime of 2y, and then don't forget the dy because you took the derivative with respect to y. Okay, so now back over to the original problem. This was like our side work here. F g prime plus g f prime plus derivative of 6x is just 6. Derivative of a constant is 0. Keep your equals. Derivative of 10y would be 10 with respect to y, dy. Okay, now we just need to clean that up a little bit. It would look better if the 2 was in front. So 2x cubed y dy plus, this would look better if the 3 was in front. And then technically we should go ABC order. So really we should say 3x squared y squared plus 6. There we go. That just looks better. I was just putting it kind of in proper form. And now you want to get the dy's on the same side. So I'm going to subtract this first term over. Okay, so on the left, we have 3x squared y squared plus 6 equals 10 dy minus 2x cubed y dy. On the right-hand side, we can now factor dy, because that's a greatest common factor, leaving us 10 minus 2x cubed y. And on the right, or excuse me, on the left, just leave it. Divide this off, because we want dy by itself. There we go. So our final answer is right there in that brown box. Okay. Couple more. Again, 11, we're going to need to do product rule on that left-hand side because it's x times y. So we're going to come to the side and do some side work. So we're going to need product, which is fg prime plus gf prime. F is x, so the derivative of that would just be 1. G is y, so the derivative of that would just be 1 with dy with respect to y. Okay, now we can go back to the problem. So f g prime plus g f prime equals derivative of 4x is 4. Derivative of negative 7y would just be negative 7 with respect to y. Okay, these ones don't do anything for us, so I'm just going to clean that up. So we have x dy plus y equals 4 minus 7 dy. Okay, now you can move in either direction. You just want to get all the dy's on one side and everything that does not have dy on the other. So it really does not matter. I'm going to keep this positive, I guess I'll add this way, but again, it really doesn't matter. So I'm going to have x dy plus 7 dy, and I'm going to subtract this y over. But if you moved the other way, it's going to look slightly different than me, but it's fine. Still correct. On the left, I'm going to factor the dy, leaving me x plus 7. And then I'll divide this. And there's our answer. So dy is 4 minus y over x plus 7. And again, if you went the other way with the moving of the dy's to the one side and the non-dy's to the other, that could look slightly different. And what's probably going to be different is the signs of things. Okay? If everything is flipped from me, you're correct. Okay? So what I mean by that is if I go back to this step right here, and I move the other way. So I'm going to be in light green pen. If I move this way and I minus the 4, so this gives me now y minus 4 equals negative 7. Is that the way I moved? Yeah. Dy minus x dy. Then I would factor the dy on the right and divide. So we get y minus 4 over negative 7 minus x is dy. What did I get at first? I shouldn't have deleted this. There we go. So see how everything is flipped from my original answer? Basically, if I just came in here and negated this whole thing, boop, boop, that would be negative 4 plus y. You can turn that around and say y minus 4, and then negate these. That would be negative x minus 7, which you can turn around and say negative 7 minus x. It's the same. It's just negated. If everything's negated, it's the same. Okay. All right, now number 12, we do not have product rule on this one. So just straight up derivative of 2x is, derivative of x squared is 2x plus the derivative of natural log is 1 over whatever you're taking the natural log of, so y, times the derivative of that bottom, so derivative of y is dy, and then derivative of negative 6y would just be negative 6 with respect to y. Keep your equals. Derivative of any constant is 0. I'm going to minus 2x because that'll leave the dy's on the other side. So we have 1 over y dy minus 6 dy is negative 2x. Factoring the dy. Dividing that off. So I would leave the final answer as negative 2x over 1 over y minus 6 answer. However, I could see people arguing that they don't like that fraction in the bottom. So if you need to, you could get a common denominator. We could say 1 over y minus 6 over 1 times by y. So I could see the answer also being 1 minus 6y all over y right there. And then I could even see, so this is what I would do. I would stop. However, if you have a professor or instructor that's really uptight about simplifying, I could see it going here, what I've got in that second red box, Or you could even keep, change, flip, and try to get rid of some of those fractions. So that would be negative 2x over invisible 1 times y over 1 minus 6y. So that'd be negative 2xy all over 1 minus 6y. And then you don't have like a fraction on top of a fraction. So I could see any of those answers. I honestly stop with that first one where I put the star. But if your teacher is really uptight about simplifying, you might have to keep going. All right, and now I just have a few more where we're going to still implicit differentiation, or actually this one's not. I'm going to, no, I'm going to keep to the topic of the video. We're still going to implicit differentiation, and we're going to use that to write the equation of the tangent line. Okay, so we will need product rule right here on this number 14. I'm going to do product rule, which is f g prime plus g f prime, where our f is x, so the derivative is 1. G is y, so the derivative is 1 with respect to y, dy. Okay, so now f g prime plus g f prime, and now derivative of negative 2y would be minus 2 dy, because we took the derivative with respect to y. Keep the equals, and the derivative of a constant is 0. The ones don't do any good, so I'm just going to get those out. We have x dy plus y minus 2 dy equals 0. So I would just go ahead and move over this. X dy minus 2 dy equals negative y. Dy x minus 2 equals negative y. Divide. And if you were just getting the derivative, you'd be done. But we're not. We're going to use that derivative to find the tangent line to the graph at this particular point. So everywhere we see y, we're going to put in 1. So this is going to give us negative 1. I'm in the light green. And everywhere we see x, let's put in 3. So 3 minus 2. So that's negative 1 over 1, which is negative 1. That is the slope of the tangent line. Okay, let me get some room here. And now to find the whole equation, we can go like this. Y equals mx plus b. We just found the slope is negative 1. The x value is 3 from the point. The y value is 1. And let's find the b. So 1 equals negative 3 plus b. Add 3. 4 equals b. So y equals something. Negative 1x plus 4, or you don't have to have the negative 1. You could just have negative x plus 4. Now that's using slope-intercept form. Some people prefer point slope. So if you do that, that's y minus y1 equals x minus x1. So that would be y minus 1 equals negative 1, x minus 3. And some people just stop there and they say that's the equation of the tangent line. I don't particularly like that. I like to go ahead and distribute it. So that would be negative x positive 3, distributing, add 1. And there's y equals negative x plus 4. So same answer. I honestly prefer the first method with slope-intercept form, but you could do either. And then I have one more problem for you, and then we're going to call it a day. We will still need product rule, so I'm going to come off to the side. Product. Right here is where we're going to need it. So our f is x, derivative of that is 1. Our g is e to the y, derivative of that, derivative of e to whatever is e to whatever times the derivative of the exponent. So the derivative of y is dy. Okay, so f g prime plus g f prime. And then now just take the derivative of negative 6y, so that'd be negative 6 dy equals, derivative here would be 2x, and then nothing for the constant. The 1 doesn't do anything. Okay, let's just clean that up. So that's x ey dy plus e to the y minus 6 dy equals 2 to the x. Okay, let's move over anything that doesn't have dy. So I'm going to minus e to the y. And then I'm going to factor dy, leaving x e to the y minus 6. The other side's fine. And then let's divide that off. So if you were just finding the derivative, your answer would be in the blue box. But we're not. We're using that to find the tangent line. So everywhere you see an x, let's put a 2. I'm going to come over here and work in pink. And everywhere you see a y, let's put a 0. Anything to the 0 is 1. So this is going to be 4 minus 1. And that's going to be 2 minus 6. So we're talking 3 over negative 4 or negative 3/4. You can put your negative wherever. That is your slope, right? When you input your values, that's the slope of the tangent line. All right, let me cover this up. And now you have your two different ways you can get your line. Do whichever one you prefer. I like y equals mx plus b. We just found the slope is negative 3/4. Our x is 2. Our y is 0. That's from the point. We want the b. So we have 0 equals negative 6/4 plus b. That reduces to negative 3/2. Add. And there's our b. So my line using this method would be y equals negative 3/4 x plus 3/2. And if you want to use the other method, I'll be in orange. Point slope, y minus y1 equals m, x minus x1. That'd be y minus 0 equals negative 3/4, x minus 2. And some people stop there. You certainly don't need the 0. So you could take that out and maybe stop there. Or you could distribute, which I like to do. That would be negative 3/4 x. Negative negative turns positive. 3/4 times 2 is 6/4, which reduces to 3/2. Same answer, either way. Okay. If you are allowed a graphing calculator, you can graph that. So I'm going to go over to Desmos. I'm not going to do 14. I'll just do 15. That was x to the, no, x times e to the y minus 6y equals x squared. Let me make sure that was correct. Okay, and then we are looking particularly at the point 2, 0. There he is. And we got for our tangent line, y equals negative 3/4 x plus 3/2. And there it is. We're correct. See how that hits the point of interest straight through just once. That's how you can check it. I could have done that with 14 as well. I just didn't want to, sorry. But feel free to go back and do that on that previous problem. Alrighty, I hope that was helpful on implicit differentiation and that you're having a great day. Hope to see you back on the channel soon. Bye-bye.